Hello, this is Faith Gilliland, and I'm going to be working on our Geometry FSA EOC review packet. Today is the first day, and we are going to work at least the first 12 problems. Hopefully, we'll get to 12. And please excuse my emails or my computer is being strange, but let's start with number 1. On a coordinate grid, AB has an endpoint, B, at 24, 16. The midpoint of AB is 4, -3. What is the y-coordinate of point A? So on this problem, you'll need to remember the midpoint formula. The midpoint formula is basically you're taking the average of your two x's for the x of your midpoint, and you're taking the average of your two y's for your y of your midpoint. So this will be, when you plug those in, you'll have the midpoint x and the midpoint y. Well, this says what is the y-coordinate of point A? And look what they've given us. They've given us an endpoint. We can call this an x1 and a y1. And they've given us the midpoint, not the other endpoint. So I might call this the midpoint x and the midpoint y. What is the y-coordinate of point A? So what you'll do, you're looking only at the y's. What you'll do is you'll fill in what you do know to figure out what you don't know. You're looking for the midpoint y. So you're going to use y1 plus y2 divided by 2. So what is your midpoint y? It's -3. It's equal to your y1, which was over here, 16, plus your y sub 2, we don't know, and then divide by 2. Now we have a simple algebra problem here. We have an algebraic equation, and to undo something divided, you multiply on both sides, giving us -6 on the left, and 16 plus y sub 2 on the right. Then to solve for y sub 2, you subtract 16 from each side, and this will give you the y of the missing endpoint, the y-coordinate. And to write this in these blanks, the negative goes in its own space, and then 22. And the EOC, you can orient left or orient right. It does not matter. Number 2 says, Susie wrote the following statements. Statement 1, if two lines intersect, then they intersect in exactly one point. Statement 2, through any 2 points, there is exactly one line. Which geometry term does each statement represent? I like to tell my students that a theorem is usually an if-then statement. Theorems have to be proven to be true. If this happens, then this happens. A definition tells you what something means. A postulate is a statement that is true. It doesn't have to be proven to be true. It just is true. For example, statement 2, through any 2 points, there is exactly one line. If you draw 2 points, there's only one way to draw a straight line through those 2 points. So given what I've just gone through here, which geometry term does each statement represent? The first one here is a theorem. It is written in if-then form, or a conditional statement. And statement 2 is a postulate. A postulate is a statement that is true but doesn't have to be proven to be true. So number 2, the answer is C. Number 3, this one might take a little while. Bart drew a segment whose endpoints are 2, 11, P is at 2, 11, and A is at 4, 3. He then wanted to find the point located 3/4 the distance from P to A. Explain to Bart, using complete sentences, how to locate the point. Be sure to give him the coordinates of the point in your answer. There is a really long way to do this problem, and I believe that is how they do it on the website where you can find the answers to this. But I'm going to actually show you a more simple way to do this problem, and it is by finding the midpoint between P and A, and then finding the midpoint between that midpoint and A, and I'll explain. Let me show you in a picture. If you draw P at, this will be kind of messy, 2, 11, and it's not going to be perfect, it never is. It's P. And A at 4, 3. And you're looking for the point that is 3/4 of the distance from P to A. If you find the midpoint by using the midpoint formula, that's 1/2 of the distance. Then if you find the midpoint from that midpoint to A, that will be another 1/2 of a 1/2, which is a 1/4. So if you've already gone 1/2, that's 2/4, plus one more 1/4 would be 3/4. So if we use the midpoint formula here, and then the midpoint formula again, we will find the point that is 3/4 of the distance from P to A. And so let's do that. P is at 211, excuse me, and A is at 4, 3. The midpoint for your x's would be 2 plus 4 divided by 2, and for your y's would be 11 plus 3 divided by 2. So the first midpoint would be at 6 divided by 2 is 3, 14 divided by 2 is 7. So that first midpoint is at 3, 7. And then the midpoint from 3, 7 to 4, 3 will give you that 3/4 distance. So we'll add together 3 plus 4 and divide by 2, 7/2, and 3 plus 7 and divide by 2. So the point that is 3/4 of the distance from P to A is 7/2, 5. And you'll have to read whatever the directions are on the EOC. They may or may not want you to change it to a decimal. They may want you to leave it as an improper fraction. Number 4 says, given the pre-image triangle ABC as shown above, find the coordinates of A prime, B prime, C prime if the triangle is reflected over the y-axis. So if this triangle is reflected over the y-axis, that means that you're going to mirror image this triangle on the other side of the y-axis. So if you notice, this is at 2, 6 over here. It's going to be at -2, 6 on the other side. That will be your A prime. Your B is at 7, 3. It would be at -7, 3 over here. Right here would be your B prime. Your C prime is at 4, -1 on this side. It would be at -4, -1 on this side, and that would be your C prime. And you connect the dots. And the correspondence, excuse my messy triangle, the correspondence that goes with that when you cross over the y-axis or reflect over the y-axis is you take the opposite of your x and your y stays the same. This is a reflection over the y-axis. Number 5. Pacquiao's geometry teacher drew the following translation on the whiteboard. Pacquiao was asked to write the translation rule that produced the image from the pre-image. Pacquiao wrote this function rule. xy translates to x minus 8, y plus 3. Is Pacquiao correct? Explain. If Pacquiao is incorrect, write the correct rule. So your pre-image is always going to be the one without the primes. So over here will be your pre-image. And oh dear. So that triangle on the left is where we start. and we're landing over here on the right. So I like to pick a point and see what's going on to go from this A to this A prime. Here's what happens, and I like to do my left and right first because that's my X. 1, 2, 3, 4, 5, 6, 7. I'm going 8 to the right. I'm going 8 to the right. So that's a positive 8 on my X. So if I were to write that rule, it would be X plus 8. So already I see he's messed up right here. And then to go from A to A prime, I'm going down 1, 2, 3. So all he did was he switched his signs. So my rule should be my original xy now becomes x plus 8, y minus 3. Page 2. Maya and Robert are working together on a class assignment in geometry. They are given the following transformations and asked to explain what transformation was used to produce the image given, the pre-image. Robert believes that the image was created by rotating the pre-image around the origin clockwise 270 degrees. Maya disagrees and says that the image was rotated 90 degrees counterclockwise. Is Maya correct? Is Robert correct? Use complete sentences to justify your answer. On this one, both Maya and Robert are correct. Rotating an object 270 degrees clockwise, 270 degrees clockwise, is the same as rotating an image 90 degrees counterclockwise. So if you have an image and you rotate it 270 degrees clockwise, my goodness, so crooked. That's 270 degrees clockwise. That will give you the same results as rotating it 90 degrees counterclockwise. And so they're both right. Number 7. Trapezoid WXYZ is shown below. What series of reflections will map the image back onto the original pre-image? So what they're asking is, how can I get WXYZ back to where it started? Which one of these 4 options does that for us? And actually, they have given us the answer first. When you reflect over the x-axis, you do the same, you go the same distance if you start down below as you do up top. And so as you rotate this thing, or excuse me, as you reflect this thing across the x-axis, it looks like it's kind of hard to see on here, but it's down 3. So it would be up 3. The x is down 3, so it would be up 3. It's a little bit off if you notice on yours. The points are just a little bit off from the marks. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It takes a few minutes, but you have to take your time and do the actual reflection. It's easier when you're on your own paper there. Okay, so there's your first reflection. And then it says reflect across the y-axis. And you don't have to do every single one. You can probably visualize this. If you reflect this across the y-axis, it would be over here in the same spot. And then if you reflect back across the x-axis, it would be back down here. And then back over the y-axis, and it will be back where you started. Okay, so you just want to look at the different options and see where they take you. And you want to land back where you started. Figure PQRS is a parallelogram with point R, negative 4, 1. What rule would rotate the figure 90 degrees counterclockwise? And what coordinate would be the output of point R? Now the shortcut for the translation 90 degrees counterclockwise is your original xy now becomes this. The y comes forward to your x and becomes the opposite, and your x now goes in your y spot, your y position. That's 90 degrees counterclockwise. That is the shortcut to remember that translation. And so that choice would be this one, where the 1 becomes -1 and becomes your new x, and the y is now your old x and stays the same. Now another way to do it is to draw this on a coordinate axis and try each one and see if it isn't a 90 degrees counterclockwise rotation, but the easiest way to do it is to remember your shortcuts. If a rectangle is rotated quickly, and one of my students said, why does it have to be quickly? But about the y-axis, what would the resulting figure be? And so if you rotate a rectangle about an axis, if you were holding a pencil and you rotated a rectangle around that pencil, the shape that you would get would be a cylinder. If you were to rotate this triangle around a pencil, you would get a cone. And in class, I can show you that if it doesn't make sense by just looking at the answer. Number 10 says, if pentagon ABCDE is rotated 90 degrees, now catch this, clockwise, about point A to create pentagon A prime, B prime, C prime, D prime, E prime, what will be the x coordinate of E prime? Well, first of all, clockwise 90 degrees, we talked about this one in number 6, is 270 degrees counterclockwise. And we have discussed, it was way at the beginning of the year, that when we do a rotation, it's always going to be counterclockwise in geometry. And so let's just remind ourselves, counterclockwise 90 degrees, just go through the different shortcuts. Your x and y now become the opposite of y, x. For counterclockwise 180 degrees, your x and y now become the opposite of x, the opposite of y. For counterclockwise 270 degrees, that now becomes y, the opposite of x. And that's the one that we're going to use, 270 degrees counterclockwise. So our original point for, we are looking at the E, clockwise about point A, to create pentagon ABCDE, what will be the x coordinate of E. So here's our E, and you can see it better on your copy that you have in front of you, is at -6, -3. That's your point E. And so your new E prime would be bringing your y forward, -3, and changing the sign of your x and moving it to your y position, 6. And they want to know the x coordinate, so the x coordinate is -3. So these are things that you'll need to remember as you work these problems and as you take your EOC. Which of the following would not be considered a rigid motion? Remember, a rigid motion is there's no change in size or shape, so you would not have a dilation. It's only a move, a rotation, a translation, a reflection, but never a dilation. And so would not be considered a rigid motion. Anything with a dilation would not be considered a rigid motion. Remember, it stays rigid, same size, same shape. All right, number 12, last one for this video. Tanya is trying to prove that corresponding angles are congruent. Specifically, angles B and F are congruent. First, the reason first she reasoned that angle B is congruent to angle D because, oh yeah, they're off with their letters here. It should say that angle B is congruent. Oh no, I'm sorry, B. Okay, so sorry. Angle B is congruent to angle D because of the vertical angles theorem. That's good. Then he reasoned that angle D is congruent to angle H because of corresponding angles. That is where he messes up. When you are trying to prove corresponding angles, you cannot use corresponding angles in your proof. So that's where he messes up. What he should have said was that angle D is congruent to angle F by alternate interior angles are congruent. So angle D is congruent to angle F because of alternate interior angles. They're alternate interior angles. So you can use another type of angle to prove in your proof, but you cannot use the same type of angles to prove something you're trying to prove. So since D is congruent to angle F, and angle F is congruent to angle H because they're vertical angles, then angle F is congruent to angle B by the transitive property of congruence. Now this concludes our first video, and we will continue our videos starting with number 13. I'm trying to figure out how to stop this video. On the next round. Thank you.